Before we will be calculating PE and KE, or potential energy and kinetic energy, let's try to identify first which of these illustrations possessed a kinetic and potential energy. A swimming turtle. Okay, a swimming turtle, from the word itself, swimming. So a swimming turtle has, of course, kinetic energy. Let's say there's a value, while the turtle is swimming, there's velocity, so kinetic energy has a value. It's not zero. But our potential energy in this case, since it's moving, it is zero. Unit of energy, could you still recall? The unit of energy, it's joule, or J. So we can have 0 J, or 0 joule. Okay. We have the value of kinetic energy because the turtle is swimming. It has kinetic energy. Now, an apple falling towards the ground. Okay. The apple is falling, meaning there's motion here. There's velocity. Okay? We have velocity. So in this case, this scenario has kinetic energy. Since it's moving, so it gains kinetic energy, and potential energy is not even evident. So kinetic energy is 0 joule. Again, J is the unit of energy, which is joule. Okay, and then we have another object here, a book on the ground. So it's not moving, it's purely resting on the ground. So if it's not moving, no velocity, no speed, so kinetic energy is 0 joule, because the book is not moving, while the potential energy is not zero. It has a value. So this book on the table has kinetic energy. Going back to apple falling towards the ground, it has kinetic energy. Okay, so we will try to solve the simple problems that we can generate from these pictures. Okay, but let me erase first some of the um, data here. All right, so again, this first picture, it has kinetic energy. The second picture, it has kinetic energy. And then we have potential energy in our third picture. Okay, what if we increase the height of our book from the ground? We lift the book all the way up to 2 meters above the ground. So the book now is in this position, okay, 2 meters above the ground. So what is the potential energy of this book? When the book is on the ground, the potential energy is zero, right? Because the book is on the ground. But what if we increase the height or the position of the potential, the book? So therefore, the book is gaining its potential energy. So let's try to find out how many joules expended as we increase the height of the book from the ground. Okay. Once and for all, if the book is on the ground, PE is going to be 0 joule. Let's try to know if the book is lifted 2 meters above the ground. What's going to be the potential energy? Because it gains potential energy now. So let's solve. Our formula is potential energy is equal to mass times gravity and then the height. Okay, I forgot to put it there. Let's say the mass of the book, it's 1.5 kilograms. The mass of the book, it's here, 1.5 kilograms. So all you have to do is to put these variables here in our equation. We have this is our height, 2 meters above the ground, and this will gonna be our mass. So M stands for mass of the book, or how heavy the book lifted 2 meters above the ground. It's 1.5 kilogram. Okay, G is constant. That's 9.8 meter per second squared. This is constant, so you will definitely substitute it to our G variable or gravity variable. So our G is 9.8 meter per second squared, and then we will multiply it by the height. The height is 2 meters. So let's multiply our values here. We have 1.5 times 9.8 times 2. The answer is 29.4. And the unit, okay, try to look at uh, this part of the screen. Let's try to multiply units. We have kilogram multiplied by meter per second squared, then multiplied by meter. And as we all know, it's understood that we have it here over 1. So we will multiply every units in the numerator and then in the denominator as well. So kilogram times meter times meter. Meter times meter, that's meter squared, times kilogram. So that's kilogram meter squared. And then we will have to, so you can have second squared here. Or we can simplify this one as kilogram meter squared per second squared. Or that's 1 joule. So the answer, you can have kilogram meter squared per second squared, or you can have joule, or 29.4 joule. So this is the amount of potential energy possessed by the object when the object is above the ground, 2 meters. So it gains potential energy. It's now 29.4 joules. From 0 joule to 29.4 joules. So I will have to show why at the ground potential energy is 0. Let's say for example, potential energy if book is on the ground, no height. So we have mgh. The mass is still the same, 1.5 kilogram. Gravity, it's constant, so you can just put it there, 9.8 meter per second squared. And then the height is, since on the ground, that's the book, so no height, 0 meter, so you can have 0 meter here. Every number multiplied by 0, it will result to 0, so that's why it's 0 joule. On the ground it's 0, above the ground it gains potential energy. Using the other picture, let's say the velocity of this swimming turtle, let's say it's 2 meter per second. That's the speed or velocity of the turtle. And then the mass of the turtle, let's say 1 kilo. So let's try to figure out the kinetic energy. Kinetic energy is 0.5 mv squared. So copy 0.5. Our mass, it's 1 kilogram. And then our v or velocity, it's 2 meter per second squared. 0.5, let's do it this way. 0.5 multiplied by 1, so it's 0.5 kilogram. And then don't forget, we will square out the magnitude and units of our velocity here. So 2 times itself. So that's gonna be 4. So 2 times 2, it's 4 because we need to square it out. And then meter times meter, that's meter squared. And put meter squared here. Over seconds times seconds, it's second squared. So that's second squared here. And then we will multiply 0.5 times 4. So you can have 2 kilogram meter squared over second squared. Or 2 joules. That's the kinetic energy possessed by this swimming turtle. Okay. Now, we need to find the kinetic energy of the apple falling towards the ground. Let's say the mass of the apple it's 0.5 kilogram. It's just hypothetical mass of one apple is 0.5 kilograms. And then we have the velocity as it moves down due to gravity. We can have, let's say, 2 meter per second. Let's still use 2 meters per second. So our formula to get the kinetic energy of the apple, we have 0.5 mass multiplied by velocity squared. So 0.5 mass of the apple, we will substitute mass of the apple in the mass variable, kilogram, multiplied by the velocity. It's 2 meter per second. And don't forget to square it out. Okay, 0.5 times 0.5, that's gonna be 0.25 kilogram multiplied by the square of our velocity. So in getting the square, like what we did here, 2 times 2, that's 4 meters times meters, it's meter squared. Second times second is second squared. So 0.25 times 4, we can have 1. And then just multiply the unit, kilogram meter squared, and then second squared. Or we can um, say 1 joule. Okay, once and for all, kilogram meter squared per second squared, it's just another way to write joule or J. Okay, I hope you learned something from our video about how to calculate the potential and kinetic energy. See you around in my next video. Bye for now.